Hey, this is Caitlin Barnes, and I'm presenting our project on science and disciplinary literacy. And Randy K. Mitchell and Randy McKeever and me worked on this project together. So we found this graphic organizer, and it's just the differences and similarities of content literacy and disciplinary literacy. And I'm not really going to go over this because, we know what it is by now. We found this cute little poster, and it's more like we would put it in a lower elementary grade. What is a scientist? A scientist is a person who asks questions and tries different ways to answer them. But it's a teacher's job to teach students to think like a scientist. Reading within science, students must use their reading skills to build knowledge. It can be challenging because science textbooks are just challenging in themselves. They're boring, they're very complex, and they're poorly written. They're not solely aimed for children anymore. They're aimed for the teacher, really. Students lose their love for science. I know I lost my love for science a long, long, long time ago because my teachers were, all right, let's write these definitions, and all right, there's your science lesson for the day. I know that we never did journals, and we never did experiments, which I would have loved experiments because I'm a hands-on learner and writing definitions are not hands-on. But you should, as a teacher, make your science class engaging, having them write in a journal, chart different things, like chart their favorite ice cream, have charts about stuff like that, which is fun, and do experiments all the time. When scientists read, they ask questions. How does an oil spill impact the environment in our case? For our lesson, they look for data-based outcomes, have students research in a journal, keep it in a journal. They pay attention to minor details and numbers. They collaborate with their colleagues, which we as teachers need to enforce that with our students because they are going to be in the workforce having coworkers, all the time. So they need to work with their classmates. They need to chart, illustrate, and graph data and conclusions. In our case, we would make a graph on their findings from their research. They ask why more than what, and they understand theories are subject to change. Science has been limited to copying notes. Just like I said before, when I was in school, we just copied the notes from the board, we wrote the definitions, we didn't have engaging science classes. We're more of recall knowledge more than understand knowledge. Hands-on knowledge is really what I needed. An interactive notebook or a science journal gets students deeper understanding of the content. They're not just answering the questions, they're drawing illustrations, writing observations, or writing dialogues with another student or students. This is getting them thinking more like a scientist. So here is some stuff we could put in their science journal. What do you see? And then after the data collection, what do you think now? What do you believe? And what does it mean? Writing within science, it's technical. Vocabulary is essential. That's what scientists write is high frequency vocabulary words. They're mostly written in bullet points. They're not writing paragraphs or anything like that. Words are minimal. They're clear. They have to be clear. They're ideas. and students must have opportunities to engage with the content, generate questions, reflect on their learning, and use writing as a tool of thinking. So we found these Banshee and Bell's level of inquiry. I'm going to read most of this from the slide. The confirmation inquiry. Its students are provided with the questions and method, but the teacher expects the students will determine a result that is known in advance. This is beneficial if the teachers want to review or reinforce learning. Structured inquiry. Students are provided with the question and method, but in this case, students generate the explanation for the evidence they have uncovered. This can be useful for scaffolding and more independent inquiry as students build a new understanding in the content areas. Guided inquiry. Students are provided with research questions, but they must design the method and result explanations. This engages differentiated instruction and targeted assessment. In the open inquiry, students have opportunities to act as scientists in the field. They derive questions, design and conduct investigations, and communicate the results. This is the most cognitively challenging stage of inquiry. I think these are continued after the lesson. After introducing the content, we would ask students questions pertaining to what is in the lesson. This is where the teacher leads the students to the answer. That's confirmation inquiry. Structure inquiry asks students to conduct research. Students can do their own research and find what they believe is to be important. They will write down their findings in their journal and then write a paper. Guided inquiry. After teaching the lesson on oil spills and reading an engaging text, we will explore by creating a simulated oil spill with a pie pan. Open inquiry. After reading the text about oil spills and how it impacts the environment, we would have students ask questions that they would like to know the answer to. Students would then investigate possible answers to the questions. So now we're getting into more of our actual lesson. So our objectives, the students will read, write, communicate, and perform like a scientist. They will learn about the effects of oil spills, and they will conduct their research along with the evidence from the text, videos, and experiment to conduct data. So setting the purpose, the introduction is really what this is. They'll watch a video about oil spills, and they will first fill out the KWL chart. The K. What do you already know about oil spills? Then what do you want to learn about oil spills? And what did you learn? Will be after the video. I'm just going to pull it up. We're not going to watch the whole video because that would take up too much time.
Hey there! Welcome to Life Noggin.
It's a really cool.
The world uses nearly countless amounts of oil every year in one form or another.
I found that video on YouTube and I thought it was really cute. And it's really good for this age that we're teaching the science lesson about oil spills. Here's a graphic organizer they will know. They will fill out what I know, so what you already know about oil spills, what you want to know about oil spills, and then after we watch the video, what you learned about oil spills. We're going to give them an article, how to go and show them how to go through it, how to really read like a scientist and collect data from it like a scientist. And the article is The Oily Gulf. It's science news for students, is where I found it. It just talks about the oil spill happened in 2010 or 2011. 2010. And it just goes through what was affected by the oil spill, what happens during an oil spill. Oops. And we're going to use this article since it's related to the topic in the model. Oh, it's the same article. Read like a scientist and allow them to work into small groups, work through the article in small groups, pull out information, and work through whole group reading. Well, first we'll do whole group, then pull out information, and if I see that they're understanding how to read like a scientist, then I'll allow them to work through the article in small groups. So like the first paragraph, first few paragraphs, we'll do whole group, and I'll model how to read like a scientist. And then if I know that they're grasping the information and understanding it, then they do it in small groups. They're independent practice. We will allow the students to get out technology, iPads, Chromebooks, Macs, whatever they have, and conduct more research. They can conduct data, so they're going to be researching just like a scientist. We're going to give them a graphical organizer to cite their sources. It's just our standard. Where did you find this information? How did you find this information? Who wrote this information? When was it written? And stuff like that. That's what this graphic organizer is. So here's our fun science experiment. I found this and I thought it was awesome. They are going to learn, or they're going to use what they learned in their previous knowledge from the article and the video to conduct this experiment. They'll use another graphic organizer to help them with the experiment. I'm just gonna pull up the what we need for I found this on scienceeducation.com. It's how do oil spills affect the environment. It has the materials. So you're gonna put clay, you're gonna build your ocean habitat, and your clay will be your land. Put some water in it. Then you're gonna add a little bit of oil, little drops of oil, and then we're gonna try to see how to get the oil out. I mean, we have pantyhose, a dropper, spoon, something, and stuff like just things that you can think of to try to get oil out. And they're going to use what they know from this lesson in the real world because this is a real world problem. This happens all the time. They will be educated and know what to do and how to prevent it. I mean, most of them are not going to go be oil spill cleaner uppers, but you never know. Here's a graphic organizer that we found. Question, hypothesis, the material they used, how they did the procedure, question, observations and evidences, and reasoning and conclusion. We will assess their learning by the project. The students will gather all the information from the video, article, and research, and the experiment, and they will use this information to graph data on a graph, and we will see how they gather the information and how they put it together in a graph like a real scientist. We'll see if they just kind of threw it together just because they had to do it, or they actually honed in on it and thought about it just like a scientist did. And that's all we got.